Invention 15. The story of the electric motor invention. In the early 19th century, people were fascinated by the mysteries of electricity, but it remained more of a curiosity than a tool of daily life. The need was clear. Society longed for new ways to power machines without depending solely on water wheels, steam engines, or animal labor. Early thinkers like Benjamin Franklin and others had experimented with electrostatic motors in the 1740s. But these devices could not deliver continuous, useful motion. What the world needed was proof that electricity could be transformed into real, reliable movement. This search for a breakthrough set the stage for one of the most important inventions in human history, the electric motor. The problem facing scientists was simple but challenging: how to convert the invisible force of electricity into continuous mechanical action. In 1820, Hans Christian Ørsted discovered that electric currents create magnetic fields, and André-Marie Ampère quickly described how these fields interact. These insights suggested a possible solution, but no one had yet demonstrated it in practice. Michael Faraday, a young British scientist with little formal education but an unshakable curiosity, decided to explore the connection between electricity and motion. In September 1821, at the Royal Institution in London, he achieved what others could only imagine. He made a wire rotate around a magnet in a dish of mercury, showing that electricity could produce rotary motion. The journey of this invention did not end with Faraday's first experiment. In 1822, he built the first surviving device, known as the magnetic rotation apparatus, which clearly demonstrated the principle of electromagnetic rotation. Others soon advanced his discovery. William Sturgeon, in 1832, created the first practical direct current motor using an electromagnet. Moritz von Jacobi, in 1834, designed a motor powerful enough to drive an electric boat, and in 1837, Thomas and Emily Davenport received the first American patent for an electric machine. Each step built upon Faraday's foundation, turning his demonstration into technology capable of doing real work and transforming industries. Faraday himself, who lived from 1791 to 1867, became one of the most celebrated scientists of his time. Though self-taught, he reshaped human understanding of electricity and magnetism, laying the foundation for modern electrical engineering. His contributions were so profound that the SI unit of capacitance, the farad, was named after him. Yet, Faraday was not alone. Sturgeon, Jacobi, and the Davenports each played critical roles in developing motors that could be applied beyond the laboratory. Emily Davenport, in particular, was instrumental in insulation methods and record-keeping, though often overlooked in history. Together, these inventors pushed the electric motor from concept to reality. The impact of the electric motor has been nothing short of transformative. While Faraday's original device wasn't practical for industry, it proved that electrical energy could become motion, opening the door to countless applications. Motors freed factories from relying on central shafts and belts, allowing each machine to have its own source of power. In agriculture, they replaced animal labor in pumping water and handling grain. At home, motors brought convenience through appliances like fans, refrigerators, and washing machines. Today, electric motors are everywhere, from tiny wristwatches to massive industrial machinery, consuming much of the world's electricity. Even now, New technologies promise more efficient designs, such as modern electrostatic motors that reduce reliance on rare materials. Looking back, Faraday's discovery was more than a scientific milestone. It was a turning point in human progress, reminding us that curiosity and persistence can change the world.